Hi, everyone. It's 5 minutes past 10, so we will get started. Again, thank you for joining our webinar, Accelerate Growth while saving 90% of your compute costs using EC2 Spot instances with auto-scaling groups. My name is Aparajita Jas. I am a Senior Business Development Manager in the EC2 Spot go-to-market team. With me, I have my co-presenter and teammate, Pritam Pal, who is a Senior Specialist Solutions Architect. Some housekeeping items before we start. The session is for 2 hours with question and answers at the end. But if you have questions during the presentation, please feel free to type in the chat window. We have team members present who can help answer. You will be on mute by default until we get to the Q&A at the end. This is the agenda for the session. I will give an overview of Spot covering the fundamentals and best practices and customer stories for successful Spot adoption. Pritam will then cover the basics of auto-scaling groups and how it can be used to your advantage to launch and maintain capacity on Spot most optimally. He will also show a demo. Now, to keep things interesting, we have a short quiz at the end on the content that we present at this session. It will also have Amazon gift cards as prizes for the top 3 winners. So please stay till the end. And then finally, we will open it up for Q&A. Let's get started. EC2 Spot is one of the 4 ways of purchasing compute on AWS, the other 3 being on-demand, reserved instances, and savings plan. Spot is the most inexpensive and flexible way to access EC2 instances. Sorry, was there a question? All right. What Spot is spare on-demand capacity that is available for up to 90% off of on-demand prices. The infrastructure for Spot is the same as on-demand and RI, with support for the same number of 89 security standards in 25 regions and 300 instance types that AWS supports. Spot helps you reduce cost on existing workloads and migrate new workloads to the cloud without increasing your infrastructure budget. This is all the more relevant given the economic crisis in the current pandemic that we are in now. So at the end of the day, you can reduce time to market, extend your runway, and build for scale. You can throw more compute at your needs, get faster results, and accelerate innovation. Here are the 4 simple rules to remember for Spot instances. Even though it is the exact same infrastructure as RI and on-demand, unlike RI, it does not require making a commitment. It is also the only way of getting the deepest discounts on EC2. It is spare EC2 capacity that you can acquire by paying by the second for Linux instances and by the hour for Windows instances. Now, let's talk about pricing. Spot pricing is a function of long-term supply and demand. The pricing is simple because it does not change often and is typically an average discount of 70 and up to 90% off of the on-demand price. To simplify the purchasing experience, we eliminated the bidding model 2 years ago. This change has made it a lot easier to get Spot instances because you no longer have to think about a bidding strategy. Now, you're probably thinking, what's the catch? It sounds too good to be true. Well, Spot is an interruptible service. If we have a spike in requests in our on-demand space, AWS reserves the right to reclaim that capacity in the Spot market with a 2-minute notification. And that's why you see here at the bottom that the best workloads for Spot are fault-tolerant, flexible, and stateless. Last and the most important rule to remember about Spot is to diversify. What we mean by diversification is having the flexibility to use multiple instance types, sizes, and availability zones for your workloads. That is the only key to being successful with Spot long-term. This explains diversification in more detail and introduces the concept of a Spot capacity pool. As you see here, C4 is the instance family, L to 8XL are the different instance sizes, and 1A to 1C are the different availability zones. A combination of an instance family, size, and AZ in each region is an independent Spot capacity pool. For example, if you could use a C4 4XL in 1A, Can you also think about using a C5 4XL or a C4 8XL in 1A to run your workloads? You probably can. So if you could, you should go for choosing as many capacity pools as can be supported by your workloads. Because each one of those capacity pools are increase your chances of maintaining your spot capacity long term. The reason why it's important to have flexibility is that spot is pair on demand capacity. So there may be times when there's a spike in demand for a particular instance type in an AZ, and it becomes unavailable on spot when we reclaim that. But if you have flexibility and have specified additional capacity pools, it increases the total number of pools available for spot that can be utilized for fulfilling your request, and therefore minimizes the overall impact of losing some of those instances if there is an interruption. Auto scaling groups can spin up other instances from capacity pools you specified in your configuration to maintain the target spot capacity that you desire.
Therefore, sorry, Prajita, is everybody able to see the screen? I see a comment about like, is anything being shared? I can see the screen, so I think it's an okay, perfect. Yeah, Prajita, carry on.
All right, sure. Therefore, when you diversify, you increase your resiliency to interruptions. Let's revisit pricing one more time. If you heard about spot instances prior to November 2017, you may recall that the EC2 spot pricing was based on bidding. Instances were priced based on customer bids, which made pricing difficult to predict and spot availability more volatile. That's not the case anymore with the current model. Spot pricing is based on long-term supply and demand. At any point, you are paying only the market price for spot. This has really simplified the pricing and consumption model for our customers. It's made the price points a lot smoother, not spiky anymore, as you see in the graph here, like prior to November 2017. There are no longer a lot of fluctuations throughout the day. Prices can change slowly over time though. Take a look at the 90-day pricing history API from your console and see for yourself that the price points are really stable and much more predictable these days. Interruptions are an important thing to understand when it comes to spot, because spot by nature is an interruptible service. You want to make sure that you're putting the right type of workload on spot. You don't want to put workloads that are stateful or long running. Putting a database on spot is a really bad idea. Now, what actually happens when we have an interruption? We will give you a 2-minute warning either through a CloudWatch event, or you can pull the metadata on the instance and you have 2 minutes to take action and gracefully move off the instance getting interrupted and bring your workload up in another instance in your fleet. There are different strategies you can take to handle interruptions, and we will cover those in more detail in the next section. Next, I want to highlight what is on the left side here. The fact that interruptions don't actually occur that often in practice. So as you can see here, over 95% of spot instances were manually terminated by the customer in the last 3 months because they completed their workloads versus AWS coming and having to reclaim that capacity. So less than 5% of the times do we have to reclaim the capacity because we are seeing a spike in demand. This data is available in the Spot Instance Advisor page. The link is here, but if you just search for Spot Instance Advisor on your browser, the first link that comes up that shows this data. While you do want to be prepared for interruptions on Spot and you do want to put the right type of workload on Spot, know that interruptions do not actually happen in practice that often. And there are different ways to handle interruptions within the 2 minutes after you get the notification. Last but not the least, one common question we get from customers is, does Spot have enough available spare capacity to support our customers? Well, good news is we indeed do. Due to the operating scale of AWS, customers are using more spare capacity on Spot every week than they were using in all of EC2 in 2014. Continuing on the last sentiment here, we have customers regularly spinning up 1 million vCPUs in a single cluster out of a single region. Western Digital is one of our successful customers that spun up a cloud scale HPC cluster on Spot. They ran over 2.3 million simulation jobs on a single high performance computing cluster of 1 million vCPUs built using Amazon EC2 Spot instances. As you can see on the right here, they did this by using a very diversified fleet of Spot. So they had multiple capacity pools they could dip into to get the target capacity. The time to results went from 20 days to 8 hours, again highlighting how effective Spot could be to scale within budget, get faster results, and reduce time to market. I talked about putting the right type of workload on Spot. Now let's discuss the specifics of what those are. At a high level, this is where we are seeing the greatest adoption of Spot today. Anything containerized is actually a good target for Spot because containers by nature are loosely coupled and fault tolerant. And we like to say that containers and Spot is almost match made in heaven. Other areas where we are seeing a lot of traction for Spot is big data analytics, CI/CD, or continuous integration, continuous delivery, stateless web services, and high-performance computing. Big data. Big data and HPC workloads really benefit from the scale that Spot instances can provide. This doesn't need to be considered an exhaustive list, though. As I mentioned earlier, any workload that is fault-tolerant, flexible, loosely coupled, and stateless is going to be a great candidate for Spot. If it is a workload outside of this list, but has the attributes I just mentioned, it is something to consider. Now, as your cloud environments and usage scale, optimizing your costs and correctly scaling becomes essential. You can use RI and savings plan with on-demand and Spot instances. This helps you mix our pricing models to best match your utilization and optimize your performance and costs. EC2 fleet and auto-scaling groups allow you to combine and scale across all these purchase models, Spot, on-demand, RIs, and savings plan. You typically use RI and savings plan for known steady-state workloads. You scale using on-demand for new or stateful and spiky workloads. And then finally, you scale using Spot for flexible, fault-tolerant workloads. A database, for example, the bar on the extreme left, needs RI and savings plan because it's stateful. A managed ML training job on SageMaker, the bar on the extreme right, can be run entirely on Spot. Now an EMR workload in the middle can be run on a combination of purchasing options, master nodes on reserved instances or on-demand, core nodes on on-demand, and task nodes entirely on Spot. Here are some real-world customer stories and what impact Spot is able to deliver for them. Lyft is primarily using Spot for cost savings. They are using Spot to drive their CI/CD pipeline. Lyft uses Jenkins orchestration of a continuous integration pipeline. Jenkins manages the builds and tests and automates the process. Deploying the code into production involved a series of tests that required large pools of compute resources. Now, because CI processes do not require a lot of power for testing, Lyft could use older generation, lower cost EC2 Spot instances and get more savings. They saved about 75% in monthly compute costs by invoking Spot using the Jenkins plugin. What's really remarkable about the Lyft story is how little effort they had to put in to start taking advantage of Spot. They changed only 4 lines of code to start using Spot and saved the 75% a month. It's a really low level of effort for pretty significant savings. Here is another success story about Delivery Hero. This is a startup based in Germany with infrastructure deployments spread over 39 countries. The company uses Kubernetes on Amazon Web Services. Amazon Elastic Kubernetes Service is Delivery Hero's primary choice for orchestrating its containerized microservices architecture. They chose EKS because it is a managed service, so they can delegate infrastructure concerns to AWS and focus instead on development. They transitioned their Kubernetes clusters to Spot to save 70% on costs. This freed up their margins and their time to focus on scale and growth. There are a large number of customers taking advantage of Spot today. Spot is continuing to grow and evolve every day since we have simplified the Spot pricing model, created more automation tools, and launched the integration of Spot with various AWS services. The top section shows those integrations with native AWS services such as auto scaling groups, EMR, EKS, ECS, batch, etc. We also support integrations with other ISVs for all the different workloads that I talked about earlier. Jenkins for managing CI/CD pipeline, Kubeflow and Databricks for big data workloads, Kubernetes and Docker for containers, and so on. The goal is to make Spot as easy as possible for customers to start using within their existing workflows, and you will continue to see that investment from AWS going forward. That brings us to the end of the overview section. I will now transition it over to Pritam to go into the deep dive with autoscaling groups, which is a key aspect of configuring and using Spot optimally. Over to you, Pritam. Pritam?
Sorry, I was in mute. Yeah. I was in mute. Sorry. Okay, do you see my right screen?
No, actually.
Which screen you see?
I can't see any screen. Not sure if anybody else can.
Okay, nope. Something happening here. Just a moment, let me do it again. What about now?
It's coming up. Yes, we can see your screen.
Cool, thank you. Thank you, Pritam. Hello, everybody. My name is Pritam, and I am Senior Specialist Solution Architect with AWS EC2 team. And my specialty area is Spot instances on EC2 World. With me today, I have a few colleagues who will be answering questions throughout this session. Feel free to interact with them. I will do a level setting first, start with the basics, and then dive deep into the deeper solutions. In next 1 hour, we'll cover some core concept of autoscaling, talk about best practices, walk you through ASG demo, how you can scale, handle interruptions, and obviously how you can save lots of money for your org by using EC2 Spot instances for your compute need. So how you provision and access compute capacity on AWS today? You may choose Elastic Compute Cloud, EC2. You can use Lambda, which is like serverless, or you can use something like Fargate, actually, which is specially made for containers, for ECS and EKS. Now you may choose to control. You may choose to use console to launch instances by choosing operating system, instance family, generation, attaching a volume, and some other parameters. Now, the same thing you can do by AWS CLI, the Cloud Formation templates, or Terraform, or any tool that you like. And then to make your application fault tolerant and scalable, you use something like Auto Scaling Group. And then we have something called Spot Fleet and EC2 Fleet, which is other ways to getting compute capacity with fine-grained control and with massive scale at a very fast rate. For simplicity today, we'll discuss Auto Scaling Group and Spot, and we'll see how we can scale massively and how we can handle interruptions. As we discussed earlier, Spot is a pricing model for EC2, and EC2 is an interruptible service. So if AWS needs to fulfill the demand rush for on-demand instances, it do so by taking away from the Spot instance pools, and it gives you like 2 minutes notice before claiming the instance. So this 2 minutes is our time when you do the automation and do draining, do the other things, the automation part. So what that means that you need to design your application keeping this in mind. If one instance is taken away, you should be able to launch new instances, fulfill those the capacity, and you keep your application up and running for the time you want. So interruption happens, but this doesn't mean the interruption happens all the time, right? So on average, if you see less than 5% of the time interruption happens, what that means, if you have 100 instances you have launched, expect 5 to be interrupted during its lifetime. And the number varies. The number varies across instance family, generation, sizes, and all. So we'll see it later. Like we'll see in the Spot Instance Advisor page how it works. So that means when you want to provision Spot capacity, you need to take care of a few things. First is the algorithm of Spot. So what kind of algorithm you want to launch with Spot? So we have 2 algorithms for Spot, which one is called capacity optimized, one is called lowest cost. So think about capacity optimized is like you give a list of instances that you can use for your application, and then AWS finds out which of this instance per availability zone in that particular availability zone has got the deepest capacity right now. And it gives you instances from that pool. Whereas the lowest cost is something that you give a list of instances and AWS find which of them has got the lowest cost at this moment and gives you based on that price. And there is something more which is called priority list. Priority list is something when you are using mixed auto scaling group, I mean, you are using Spot instances on demand and matching reserve instances and savings plans. So maybe you have bought some reserve instances or RI in your process, right? You want to use that first. So priority list is the list that you give in your auto scaling group that helps you to use the reserve instances first for the on-demand portion of your fleet or your auto scaling group. Now, what you do with mixed auto scaling group? First of all, you reduce cost because you are mixing all type of purchasing options. You're using Spot, you're using on-demand, you're using reserve instances, savings plans. Then you optimize for performance. That means you are always up to date with your need. If your need, more and more need comes, you do dynamic scaling, auto scaling. So you never are out of capacity when you need it. And you also eliminate operational overhead. That means you don't ever have to wait for your instances, for your load to max out your capacity. So you can have a tracking capability as your loads come, you grow before that, right? So all the things you can do with auto scaling group. So if you combine your purchase models and you create auto scaling group, the screen looks like this. I'll be showing the screen to you like in a little while you go to the demo, but I just want to show you what all this means actually. Okay. So see on your left-hand side, you go to options, like the steps, how you create auto scaling group. You put the purchase options, like combine the purchasing options, then you give the instance distribution, how you want to do, how much you want to do on demand and Spot, the allocation strategy. Then you pick the instance types that we will talk about in a few slides. So, right now we have got more than 300 type of instance choices on AWS, right? Which instance is best for you? And you can go to UI and search for those things, obviously, and get done and find out which is the most important or instance that you want to use, right? People typically start with M type or T type, then they find for big data we need something with higher memory, which is R type. For machine learning, we use P3 or the GPU-based instance like G type, G3, G4. For compute optimized, we use C5 type, right? So it is easy to see from the console and make a list of instances you want to use. But we have also launched something called EC2 Instance Selector tool that you can download from the GitHub. The link is right here, or somebody will put the link in the chat if you want to see. So it is a small standalone tool, but very nice utility. You can just install in your local system as a standalone and run some queries to get the instance type you want. Or you can it's a Go library, so you can also directly integrate that with your code. That means you don't have to give a list of hard-coded instance types ever again in your templates. You can just query it and get the output working for you. How it looks like, what is the output kind of thing? So you run EC2 Instance Selector. You can search by the memory. Like in this example, I am asking for give me instances which has got 4 GB of memory, 2 vCPUs, and the architecture is like x86 64, and from the region US East 1, which is North Virginia. It gives me like 5 instance types. Now it doesn't give me anything more than that. It is okay if you want to just grab the output and put in your what you call your code. That works great. But just if you want to see it, like about more information about that, then you can use this table-wide view actually, which gives you more information about it. Like it gives you information about the hypervisor, are they Zen or Nitro, are they current generation or not, if they support hibernation, about CPU architecture, what is the networking performance, how many ENIs are there. There are lots of other options. If you go to a tool, you can see about it, and it works. It helps us to select the Spot instances, because when you use Spot instances, we always recommend that you use multiple instance types, multiple instance families, because 1 or 2 instances family have got more pressure. We can have surge demand, they get interrupted actually. But when you use more and more instance types, if you don't get one or one get terminated, you get something else from another instance family or generation or size, right? So before we go to the demo, we'll talk about a few of the other algorithm techniques that you typically want to use for Spot. So think about this screen actually. Think about let me see my pen. Okay. So I want 12 capacity, and I said my base. I don't need a base on-demand capacity, and I don't want any on-demand in my fleet. So in my auto scaling group. So I need everything Spot, and I am giving a 3 instance types actually, or sizes you can say. So you can say R5 large, M4 large, and M5 large to make it easier and fit the screen actually here. And I'm selecting an allocation strategy, capacity optimized. Now think about a region like North Virginia, which has got 6 different availability zones. But in my case, I'm only using like 3, 1A, 1B, 1C. Now, all these 3 instance types, these are the prices for them. It's got low price, a little bit high price, a little bit more high price. And think about these prices doesn't vary much because they're already discounted 60%, 70%, 80%, 90% based on the on-demand prices. So the difference is like typically very less. Now, this is the kind of pool they have. There's no number assigned to it in the screen, but just see how much pool they have. So in this case, in 1A, R5 has got the deepest pool among all these 3. Here, M4 has got the deepest pool. Here, M5 got the deepest pool, right? So when I try to launch Spot using capacity optimized, it will give me instances from the deepest pool. So in 1A, I get from R5. In 1B, I get for M4. In 1C, I get from M5 again. What that means that you are cutting down the interruption percentage, because if you are getting from the deepest capacity, chances of interruption is always low, right? And that helps many of our customers to get the interruption, bring the interruption down. Now, there's one more strategy actually, depending upon workload, in which you may want to spend the lowest price possible on the spot market. So here I am giving an allocation strategy called lowest price. Just a minute. location strategy is like lowest price, and I may choose one low price or lowest two prices actually from there. So here I'm giving a pool size of like instance pool size of 2. So I have got 3, so 2 is optimal, or 1. If I have more number of overrides here, like 20, then I can put it like 3, 4, 5 also. What that means, it will check for, now it will not check for the capacity at all. It will just check for the prices. So the 2 lowest price here is like this one and this one. Here, this one and this one. Similarly here, this one and this one. Now, if I try to run my auto scaling group, so I'll get instances mix of both R5 and M4 from here. Similarly here, and similarly the lowest 2 cost from here. So you got choices. Either you go for the lowest price, or you seek for the optimized capacity optimized. So it is up to you. People have different workloads and people use it differently. So there are many options, mix and match you can do. Now this I showed, this can be implemented on your auto scaling group, which I'll be showing to you through console or through Terraform or through cloud permission template through CLI. Now I'll talk you something about weight also. So in my earlier example, if you have noticed, I have used instances of similar vCPU size. So they all have got same vCPU. Now, if you mix instances which have got different vCPU size, what about that, right? So let's say you have got instances X large or 16X large, they're not of same size, right? So what you do in that case? So one instance of like XL and one 16XL has got huge difference in the size. In that case, we can still do it. So what we do in that case, we use something called weight capacity, or we can weighted capacity, and we give a weight to your instance. Now this number is a number that you define. You can define this number by the number of cores they have, or simply by the size that you have. Okay, so let's say I have got a M4 16XL. I give a 16 size of it, and I give a 24XL. I give 24 size of it, and then I can define, now everything is now on a unit base. It's not a number. It's not a number of instances here. Now, if I'm looking for 160 as a base on demand, that is mean 160 units of units. This units would be like divided between these two boxes. So I may get 10 of it or 8 of it kind of thing. So I am asking for desired capacity is like 480, which is like 30 instances of this or 20 of this. So you have got option now to do that. So I'll be showing that option to you also when I go for demo. So you can keep instances of similar vCPU or diverse vCPU, doesn't matter. You have got the option here to work with different kind of things. Interruptions. So as you know, Spot by default, by nature or by design is an interruptible service. That means interruption will happen. But that doesn't mean that your application or service has to go down. We'll teach you how to handle interruption, and that too gracefully. So the simplest option to handle interruption is that we publish a EC2 instance metadata in that instance whenever Spot interruption happens. So we give you 2-minute notice. We send you interruption notice to CloudWatch and also to the instance metadata. If you're gonna pull this metadata, this link doesn't work from outside, but inside your EC2 box, this link works. So you can go to your EC2 box, ping this link, you'll get various EC2 information from there. Now, when you put a sleep of 5 seconds, that means every 5 seconds you run a loop to check for the instance state. Whenever you get interruption, you will read that. So interruptions are typically, we give like, sorry for bad writing. I'm using my touch screen. Yeah. So you get 120 seconds to get up to 120 seconds to get the interruption notice. That means if it is runs every 5 seconds, within 115 seconds left, you'll get the interruption notice. And then you can do lots of automation what to do. So one option is that you can gracefully get your in-flight request out of the ELB or ALB. Second thing, you can detach that ABS volume and keep it for later. You can upload some logs to S3. So you have different options are there, different solutions are there that you can do. So this is that like DIY, like do it yourself kind of thing you can do. Otherwise, we have rolled out a solution that you can use. So here we use Amazon Event Bridge, which is like a rule-based engine. So again, this is like open source. We have done this open source. You can download from GitHub, or you can use the serverless application manager tool in AWS side to download this and deploy the Lambda. This is a Lambda-based application. What it does, it automates your thing through a Lambda. So whenever there is a detachment, whenever we have interruption, it detaches the instance from the load balancer and replace a capacity instantly. So I get interruption notice, I get 2 minutes time to draw out or drain my instance. Meantime, I'll just start it. I'll start another instance actually quickly so that my capacity is never less. By the time this instance goes away, I get another instance, right? You can run particularly lots of commands for graceful termination or any kind of automation you want to do, you can do with AWS System Manager tool. And then if you want to use some notification logs or something, you can always use the SNS service. We typically say don't send any notification for like Spot instances. Keep it automated. You don't have to worry about Spot coming and going. Just leave it there. Automate things. It will take care of everything for you all. Okay. Now I'll go to the demo. Okay. Demo will take like, we'll go to a demo. We'll show you things from start to end. If you have any questions, you can put in the chat and I can highlight those things in my demo. Otherwise, I'll just wait for a few seconds and move to my console and start there. Okay. Just a minute. Okay. So what we're going to do in my demo today, we are creating a web application. We will be using our existing VPC, what we have here. And in the VPC, I'll be creating some availability zones, which are already there. So just for simplicity, I'm using 2 here, but in the application, we'll be using 4. I'll be creating one load balancer that will be taking the traffic from users. And then I'll be creating auto-scaling group, a mixed auto-scaling group with Spot instances and on-demand instances. Then I'll be serving my application through this through the Spot instances. I can have everything Spot, but I'll keep a little bit on-demand also to show you the difference between Spot and on-demand. And then I'll go and create the event bridge. I deploy the Lambda application to deploy the event bridge application in my Lambda. And then it will create some rules automatically for me. And then I will do a test run to see when interruption happens, how I'll mock an interruption actually. It will not interrupt the box because it don't interrupt the box, but I'll do a mock how if that interruption happens, what exactly happened, how did like a detached in load balancer level or auto scaling group level, and how that new boxes are created actually. And we'll also maintain a diverse set of instances in the fleet, and we'll see those things, how to lessen down the impact and all the things as we go forward. Okay. So let's go to screen. Okay. Not. Let me hit this. Okay, sorry. Let me go back to my console here. Okay, right. So this is my EC2 console here. Is my screen all okay?
Yes, Pritam, we can see it.
Thank you. So first of all, this is EC2 screen. If you have seen this kind of screen, that is fine. Otherwise, you'll be seeing something like this, which is like old screen actually, like this. So I'll move to new screen actually, which is give you more options, more visibility of things into things. So then in new screen on left-hand side navigation pane, I'll go and create my load balancer first. So I go to load balancer, and here I'll create load balancer. I just take application load balancer. I'll say create, give the name, like I can say spot webinar, and I'll keep it internet facing to take traffic from outside IPv4, and also I have a listening on port HTTP 80. Typically you will be doing HTTPS, but to keep it simple, not to use in the certificate, I'll keep it HTTP 80. Now I'll be using my default VPC, and I'll be using all 4 availability zones. What I have here, West 2A, 2B, 2C, 2D. I am using my Oregon region, that's fine. Tags are optional, that's fine. I'm not using a tag. Configure security settings. I'll just give me warning because, and I am using a security group which has got HTTP open to the world, like port 80 open to the world. And then I'll configure my routing. That means I need to create a target group. I'll keep it a name like webinar TG. And it's again, target type is instance, protocol HTTP, listening port 80, and the health check will be, I'll be installing a Apache server actually, HTTPD server. So that will be listening in the root path. Health check, I want to do the health check faster for this demo. So I'll keep the interval 10 seconds and threshold also to 2 times. Everything else looks good. For registered targets, I don't have any EC2 boxes running as of now. So I don't register anything as of now. Let's go to review and create. So this will create the load balancer for me, which I can see the DNS name here. If I go and do it, nothing should come because there's nothing on behind. I have created a target group also. If I go to the target group and targets, there's no target here, right? Now I'll be creating a launch template, which is kind of a blueprint for your auto scaling group. I have a launch template already created there, but I'll create one from scratch for you. I can say name, I can click create launch template, give the name webinar launch template. Then you have to, if you select this box, it will guide you what are the things you need to do with auto scaling group, mandatory thing you need. So I need an AMI, obviously. To keep it simple, I'll be selecting Amazon Linux 2 AMI. The important thing to note here, I'm not giving any instance type here. I'll keep it blank in my blueprint, in my launch template. I'll be overriding all the things in my auto scaling group. So what I am doing, I'm just giving it a name and then just giving an AMI ID to it. I won't log into the box, so keeping the key pair blank. I'm using my VPC and not the classic one. And security group, I'll be using the security group that I already have, the load balance security group. Keeping the volume same and resource tag same. Okay. And then I'll be adding some user data actually that I need to run my HTTPD application. I'll just paste them here. So it's a bash command, install an Apache server here, and it will echo, this is my test site and instance ID, which will be getting the instance ID from the instance metadata, right? That's all, the simple application, nothing there. So I'll go ahead, nothing else to change here. If I see, and then I create launch template. Now my launch template is created actually. So I'll be seeing it here coming up, webinar LT. Then I'll create my auto scaling group. Now all the fun begins here. So I go to auto scaling group. Okay, fine. Create auto scaling group and give a name. So I can create webinar 17th July. Then I need to select the blueprint, the launch template. If you don't get it first time, just refresh this tab. And I have this webinar ID. It will show me the AMI ID, this and security groups and other things. Instance type is blank. I go next. Now I'll go and explain all the things to you. So what I'm doing, I'm combining my purchase options and instance types. That means I am combining on-demand instances, I'm combining spot instances, I'm also combining different type of instances here. So let's first discuss about the instance distribution. So it says optional on-demand base. So which is on-demand base? That means, let's say you have an auto scaling group and your desired state is 20. You say you may select that out of the 20, give me the first 10 from on-demand, and then rest 10 divide between on-demand and spot. And that's the ratio you can give. And those things can change. Like in my example, let's say I want to go for size 20, but I want to keep on-demand least possible. I may not use on-demand at all, but let's see, I give on-demand actually. I'll keep 2 on-demand. So out of 20, this 2 on-demand goes. Rest, I have got 18 instances. And in that 18, I'll split between 10% to on-demand, 90% spot. So 1.8 on-demand, that will make it 2. So you'll be seeing 2 plus 2, 4 on-demand instances and 16 spot in this case. So you can change this ratio anytime, even after like starting the auto scaling group, if you feel so. Or you can just go 100% spot. Now coming to the allocation strategy. So allocation strategy is something that I have shown you earlier. I can go for cap optimized or I can go for lowest price. Cap optimized, we recommend all our customers because it checks, it is like algorithm that checks about the pool capacity and then gives spot from the deepest pool. Then what I will do, I'll keep it cap optimized. Then I'll select my instance types because I haven't given any instance type. I haven't given any instance type earlier, right? So just keep an eye on the screen for a second. Look at this space. This space is blank right now, right? As soon as I choose the instance type, let's say my favorite instance type is M5 large, let's say. You drop down, you get all the instances actually in this list with showing how much CPU they have, how much memory they have. Let's say I select M5 large, which has got 2 vCPU and 8 GB of RAM. As soon as I select this, a whole list pops up and down. So this is number 1, and you see additional instance types are popped up here, up to 20. So what are they? So it says family and generation flexible. That means I am keeping the vCPU and vCPU same, and I am playing with the memory and some memory stuff here. So first it will give you the instances which has got exact core and vCPU. So M type is 1:4 ratio. So it will give me 1, 2, 3, 4, 5, 6, 7 other instance types, or number is there. So it will give me 7 other instance types, which has got exactly same configuration by the number of vCPU and core. Maybe the generation is up and down here and there. Like I got M3, M4, M5N, M5AD. And then it will go and give me other instance types also, which has got lower or higher memory. So if you go R type, it is like 1:8 ratio. So 1:8 ratio. If you got C type, it's a 1:2 ratio, right? Now, if you think, no, I don't want to use R type for my application, so I don't want to use R5D, you can just cross it. Okay, no question asked here. You can cross and you can keep as many as you want. The list goes up to 20 in West region. In some of the region, you may see up to 15 or 12. Okay. Now, if you see the weight option is blank, but if you, because they are of same size, you can say, but still you can go in and give a weight to it. Now, if we if you want to mix the different vCPU sizes, actually, you select size flexible, and now it pops up with different information. It gives you 4 vCPU weight, 32 up to 96, and it also gives you a weight actually. So now it is trying to keep the generation and family same and gives you more option about different weight option. Now, if you want to go with this, and if you request for 1,000 of units, you may get 500 from M5 large, or maybe 100, like 10 or 12 from M5 24x large. It mixed like that. So weight option, you can play with this. If you think this is not a right weight option, you can change the weight option. We won't go with the weight option for this demo. I'll go with the family and generation flexible. I'll just select all the things. So when I select capacity optimized, what it will do, it will give me, out of these 20 instances, it will give me which instances has got the deepest pool right now from the availability zone I select. So I select 2A, 2B, 2C, 2D. If you remember my example, from each of this availability zone, it will go and pick the best instance type, right? Okay, so the deepest pool. So I am going with the default, and then coming the priority list. So if you see the number is written 1, 2, 3, 4, 5, 6. So for the on-demand portion of it, like this 4 on-demand, like 2 from here, 2 from here, for this size I'll select. M5 large, so on-demand portion, they will try to fulfill with M5 large, because you may have a matching RI bot, right, with that size. And then for, if I don't have M5 large, it will try to fulfill by the next generation, next in the list. So if you only want to use M5 or M4 for your on-demand portion, I can do this. I can move this M4 up actually. I can move this up. You can do everything what I am doing here through your CLI or Cloud Formation template with your Terraform. So no worry about that, right? So if I don't get an M5, I fulfill by M4 for the on-demand portion. The spot portion will be fulfilled by the logic, by the algorithm of cap optimized here. So what I'm expecting here, I'll be getting one instance types from here for this AZ. It can be same. If one type of instance has got the deepest pool in all the AZs, I'll get same type. Otherwise, yeah, I'll get a mixed type. Go next. Enable load balancing, which is important because I'll be fulfilling the load balancing. Load balancer, which I created earlier, webinar. I'll select the webinar. Health check is fine. I can keep it 300 seconds. I can keep it low also. And then I'll keep the desired size, which I said 20, minimum 20, maximum 30. I can also scaling policy. I can add a scaling policy here. If my load increase, if my average CPU utilization increase beyond 50%, okay, give me more instances, right? So you know about tracking policy. So you can just, I'll keep that. I don't use that for this demo. Just keep this. Go next. Notification, I don't need notification because auto scaling group keeps on going up and down all the time. I don't want to get a mail about that. I need to add some tags. The first tag, I will give a name to it, like webinar. And I need one more tag actually for the interruption handler. So I'll explain this later. Just remember, I'm adding a tag here called interruption handler, and the name will be true. So this I'll be needing when I use the interruption handler, actually, the tool that I talked about before. So true, interruption handler enabled. Next. Now again review it. On-demand base 2, and then on-demand base 2, then 10% on-demand, 90% spot. I'm using capacity optimized, 20 different instance types. It shows you the network performance, etc. Load balancer, health check, EC2, monitoring disabled, group size 20, 20, 30, and tags. And I create my auto scaling group. Now it will take some time to give me the auto scaling group. So I can track it here. I can also see my EC2 dashboard. Meantime, what I'll do, I'll just open another screen and install the Lambda, the interruption handler tool. So you can go to serverless application repo actually. and repo, go to available application, choose this show app that create custom resources AMI policy, search for Spot here, and you see EC2 Spot interruption handler. Just select it. It will ask you for some settings. We need to give the SSM parameter of the auto scaling group name here. So what are you giving from here? I know the name, right? Auto scaling group name. So copy the name from here, go to my Lambda deployment, give it another tag, acknowledge that, and deploy. Okay, it will take like roughly 2.5 minutes time to deploy the application. I'm not going into detail of the application, what it does, how it is created. You can go to the GitHub page that somebody will be posting the chat, or we'll be sending all the slides and the links to you after this call. Actually, it will take some time to deploy. Meantime, go back to our console and see what's happening here. So my auto-scaling group, I asked for 20 instances, and what's there? I got 20 actually. I can go to my EC2 dashboard, refresh this. I get 20, which is nice, right? I go to instances and see, yeah, I've got this. Now this view may look a little bit different from how you see it actually. I have kept it very simple, just seeing the name, instance ID, instance type, availability zone, running instance state, launch time, and lifecycle. This lifecycle is very important. So if you don't see lifecycle in your screen, go to this gear icon actually here. Okay, and then you select this lifecycle from here. Okay. Now a lifecycle you select from here and close it. So what we'll be seeing, if it's showing normal, that means it is on demand, or it can match to reserved instances. And if it's spot, it's spot. So as we discussed earlier, we'll be getting 4 non-demand because 2 from the starting part, 2 from the ratio what we gave, and rest spot. So now you know these are coming from spot and these are coming from on demand. Now let's say I do some shorting here, lifecycle equal to normal. What I see, I got all my on-demand, which is across all the AZ, like distributed across all the AZ. I got from M5 large, right? What I expected, sorry, because if you see here, M5 large was my first choice of instance. So the on-demand portion is fulfilled by M5 large, which I expected, right? Now about the spot portion. Lifecycle equal to spot. Now if I see, I just sort by the availability zone. So if you say, I can filter availability zone 2A. If I say 2A, I got from M4 large, right? So 2A I got from M4 large. That means out of the 20 instance type that I gave there, in 2A, I've got M4 large, the deepest pool. In 2B, I've got M3 large, I've got the deepest pool. Then again, 2C, I got M4 large, again deepest pool. And 2D, I got M5D as the deepest pool. So now you don't have to worry about anything, like from where my instance is coming and going. You are getting the deepest pool from all the AZ, the best of the all worlds actually. Now, if I go to my auto load balancer, I'll be seeing the same thing actually. I'll be seeing the target groups. If I go target groups here, I should be seeing the instances attached to my target group. I go to targets and see, yeah, I see all the instances coming here, which are healthy. I can see like 30 resources. Yeah. So all the instances are here healthy. That means I should be able to serve traffic from my load balancer, which is the DNS name here. So which I copied earlier here, which was not giving anything to me before. I'll just make it, no, Yeah, so that looks really bad. So this is my test site and instance ID is this. If I keep on refreshing it, you should be seeing this changing. So refresh it, see it's changing. So that means the traffic is routed to in round robin fashion to different instances. Some could be spot, some can be on demand, right? So you keep on doing it endlessly, it will keep on going traffic to different boxes. So now your web application is serving traffic from your both spot and on-demand instances. At this level, you won't be feeling any differences, either you are using on-demand or using spot. That we want to convey to you. Now, we are good here. So I know the instances are running everything, but interruption may happen. Okay, so how you handle that? So to simulate the interruption, what I'll do here, I will select instance from this list, which is my script got today. So I'll check this one. Let's see. I'll mark this as like target to be interrupted. Okay, I'll take this instance and I'll interrupt this instance. Okay, how I'll do it? I'll go back to my Lambda console, which should have deployed my application. Cool. I need to test the application. I go and test the application here. You can see this in Lambda console actually. So if I go here and go to the Lambda function, you can see Lambda function and all handler. You can see how the Lambda is written. It is fulfilling to event bridge. I can show you that too actually. Hold on. Let me go to Cloud Watch. So this Lambda setup is done through a cloud formation template. That also I can show you. So if you, after deploying the application, you'll be seeing something coming up in the serverless pro EC2 spot interruption in your cloud formation stack. So I go to CloudWatch, I go to event rules, which became event engine rules now. You can see a pop-up here. So I have a rule created here called Event Pro, Event Serverless Pro, which tracks for the spot interruption notice in the EC2 metadata every 5 seconds. So as soon as I get interruption here, it will get the interruption details and trigger my Lambda. Now, what is my Lambda? You can see my Lambda here, what a Lambda is all about. You can see the code here. So what it does here, it comes and it checks for all the information that we have here, if the tag is matching, and what is the instance type, part of the auto scaling group or fleet, and then what to do after that, right? So you can go and see that. So what we'll do today, we'll create a test event and run the test event, run that test event actually. So I go to test and I need an event, right? Let's call it event. I need a code base to run the event actually. So just a moment. This is my code base to run the event. So what I'll do, I will need to change the instance ID here. So this is my script route. I'll take the instance ID from here, copy it, and Lambda, paste it there. Typically, you don't need to change this resources name here. That's fine. I'll just save it if it doesn't work. If it doesn't work, I'll go and change it to create. I have got test event in which I am simulating interruption. Like this instance has got some interruption. I am simulating that actually. Now, if I go to my auto scaling group and I go to activity and search for this box, I get only one notification that this got launched, right? If I go to my target group, sorry, if I go to my target group, I'll be seeing it is serving targets all the targets are there. If I filter it by the instance ID, it is showing webinar target to be interrupted. It is healthy, right? Good. So it is healthy here. Now I'll go here and attack my Lambda, right? When tested. If everything goes good, I'll be seeing a success notice here. Yeah, it shows interruption response action completed for this belonging to this auto scaling group. And the interruption, the instance was detached from webinar like auto scaling group. There's no system parameter, and then we do few things. Now, if I go to my EC2 console and refresh this page, what you see instantly it is started trying to drain my instance, which I think got a spot interruption notice. That means you don't have to do anything. When this happens, within 5 seconds, your instances will start trying to drain the things from your load balancer. And if you go to target group, you'll be seeing target deregistration in progress. And instantly, it gives up you start a new instance also in response to that. If the new instance or not, copy this ID here, go to your EC2 console, and if you refresh it, you'll be seeing one more instance coming up here. So just write the name. Sorry, I can just sort by launch time and see this guy came up, right? So yeah, at 10:23. So my other instances came up earlier, like 10:59 a.m. But this one came, this one came in response to this instance being an interruption notice, right? Now now that means now this instance is out of my auto scaling group. It is not part of my auto scaling group anymore, right? But I got an instance new to fulfill the capacity, and it is getting from same availability zone from where the interruption happened. So if I do this again and again, if lots of spot get interrupted also, I'll get an interruption. I'll get a replacement as soon as I get the termination. So everything is automated here. Think about that. If you're interrupting 5 or 10 boxes also, this Lambda will go and drain those 10 instances. Like it even okay. One thing I forget to tell you. So when you see the target group, you need to edit some parameters for in here actually. So typically the deregistration delay is 300 seconds, which is like roughly 5 minutes, but spot interruption gives you 120 seconds. So that means the 300 seconds is not ideal for your use case. So you want to make something which is lesser than 120 seconds, right? So you can say I put it something like 90. So I'll want to wait for 90 seconds for my in-flight request to be completed, and then give some more time to my auto scaling group, right? So you can do it 90 for spot instances, save changes. So now onwards, if any interruption happens within 90 seconds, it will be taken out from the pool. So to summarize, I create auto scaling group with mixed purchase option, with lots of spot and some lots of spot, some on demand, then running an application to it using my auto scaling group, within serving traffic. And now if an interruption happens, it automatically is handled. So my auto scaling group is always at the same number of instances that I wanted. Now it has got 21 because there's one more instances that actually didn't stop. So we kind of said it got stopped, but in our case, it didn't stop at all, right? Because we just simulated the interruption. So in real life, this instance will be down by now. So it will be like terminated in two minutes, right? So your auto scaling group size will be kept same actually. Now we have talked about for last 1 hour, 15 minutes about spot, but how you see the savings, right? So to see the savings, you can see spot instance advisor page that we told you earlier. You can go here, choose your region. I'll be choosing, let's say, Oregon region is close to me. And I can see what is the savings versus on demand. which is roughly we get lots of saving percentage and saving of percentage. So you can short via this, you get up to 90% savings actually. And there are some instances but high interruption rate, because if it gives more saving, people will try to use those things, right? But there are still some instances which has got lots of savings and interruption rate less. So that is up to you how you want to mix and match things. You can go with search via some lowest CPU number you really want, and then or sort by the frequency of interruption. This everything you can do through APIs also. Now, what is the price I paid? So this doesn't say about what is the on-demand price, because we have other ways to get the on-demand price and calculate the difference, but I'll show you that too. If you go to EC2 console, under instances tab, go to spot requests, and then the two things will come up here. One is saving summary, one is pricing history. Pricing history will give something for each of these products, like Linux, SUSE Linux, Red Hat Enterprise, Windows. For each instance type, what is the price? How is the price for last 3 months? You can select 3 days, 3 hours, 1 day, 1 week, 1 month, up to 3 months. Let's say I give M5 large. So if you see M5 large, we have got 4 different AZs actually in West 2, and 2D M5 price fluctuate a lot. So I don't want to use that, right? That means it may have got less capacity also. I may think so. So in that case, I have got 3 other AZs which has got priced almost between 0.03 to 0.04. If I go select M5X large, you'll be seeing, okay, some differences. M5 4X large, yeah, price fluctuates, right? But if I see the, okay, ignore this blue one, maybe some new, is like new availability zone maybe. But if you see otherwise, the prices fluctuation doesn't vary that much, right? It moves from 0.3 to 0.4. I can go for other families also and go for like C type, let's say. C5, the latest generation, X large, where prices again go vary. Go to C4, maybe go to C4, X large, and see what is price. So here you see the price almost is like flat for last 3 months, right? So you can do those things of your own and price the prices. But now how much it paid for the lab I ran, right? There's something called savings summary. You can click here and you will see I ran today 17 spot instances, which is 34 VCP hours. This is the memory RAM I used. If I used it for on demand, until now, I roughly ran for a few, like 1 hour kind of thing, it would be cost me like $1.80. But on the spot, totally I paid today is 57 cents. That's all. Compared to $2, approx $2, I paid something like 57 cents, which is 70% savings actually. So this is my cost per core per vCPU, like roughly 1.67 cents. And it gives you all the instance types that I used today. So I used M4 large, M5 large, and M3 large, and what is the average saving. You can see all this data through your cost explorer at the month end or regular basis. And yeah, so that is something that if you wanna use spot instances, you can go and like talk to your management, or you can also implement of your own if you want to do that. So that's been said actually. So yeah, that being said, so you can, like, this is a screen graph from earlier. So when I used like large instances and how much would have been cost on demand then for longer time actually. And yeah, the screenshot about that. And the integration, as I told you earlier, Spot has got lots of integration with the open source tools. Like we have got excellent integration with you can say about Jenkins. We have got Jenkins plugin, like for your CI/CD. You don't have to do anything. Just install the plugin, and whenever you want, and just install the master on, or like primary on demand, and rest all the worker instances you can just start on Spot whenever needed and run on spot and kill them automatically. You can do those things. We have got labs when you can go and check out those things. Actually, this is a open source page in GitHub where we are started putting our details about what are the integration we are doing currently and what is the probable date of shipping and all. So if you have some workload that you think is blocked they cannot use Spot because of some limitation, and that needs a third-party integration, you can talk to us about that. You can influence us with that, and we'll see how we can get it going. Spot, we are investing a lot on Spot. That's why you'll be seeing lots of blog posts and tutorials coming up. So we have got some 10 to 30 minutes tutorial, we'll say. So the tutorial that I ran today, like the whole lab, if you run of yourself, you can follow this link, the first one actually. And then if you want to run Kubernetes on Spot, you have some other tutorial. You have got excellent support, out of the box support for EMR, for batch, for machine learning with Spot or the Spot SageMaker. So these things we'll be talking about our next two webinars actually. If you do some hands-on, actually, we have got 7 to 8 self-paced labs in EC2spotworkshop.com. Step-by-step instructions are there, which is great to understand how Spot works for your workloads. If you're ECS enthusiast or Kubernetes enthusiast or machine learning enthusiast or web application, EMR, just go there and do those labs. EC2 Spot Labs is our GitHub code base actually, where you can go and see the codes we have put there. And there are lots of codes. I have seen my customer use them on go-to-go basis because they are readily available and they are mature code that you can take it and use in your systems actually. Yeah, that being said, we have more blog posts that has come up in last few months, whatever we have learned from our customer, and then we implemented few things. So if you want to use Fargate, you can use the Fargate blog, deep dive into Fargate, then run a web application which is Spot. We have got CI/CD blog, and these blogs are typically a detailed blog about how to really implement something for your workload. Okay, and then some customer blog post we have how customers has used Spot. This is an excellent blog from Mobileye and Skyscanner, and also from Instant Digital. With this, I'll be handing over to Aparajita for talk about the next part before we move to the quiz.
Hey, thank you, Pritam. Everyone, hope you found that session helpful. These are the, Pritam, do you want to build out the slide? These are the main takeaways we would like you to leave with. Spot pricing is simple, no bidding since November 2017. Well-architected Spot with a diversified fleet can really reduce interruptions. Spot has better console experience and improved integrations with multiple AWS services and ISVs to reduce frictions for adoption for our customers. That's been a goal for the AWS service team, and you would continue to see that investment going forward. Lean on EC2 Auto Scaling groups to launch Spot instances. It is the best fit for a lot of workloads, and adopting the new and improved auto scaling groups will future-proof your cloud deployments for following cloud best practices. Finally, let ASG and Spot Fleet, whatever you choose to adopt, provide the required capacity at the lowest price. If lowering cost is your main driver could be lowering interruptions. So then select the Spot capacity from the deepest pools with capacity optimized strategy. Now this, along with the well-architected Spot, like with a diversified fleet of Spot, choosing capacity optimized with a diversified fleet of Spot can really lower interruptions, which is one of the biggest fears I think we hear from customers, and that would be the way to mitigate that. Next slide. And here is the agenda for the event next Thursday, the 23rd. It's a deep dive on Spot for containers. Excuse me. As I had mentioned earlier, containers is by far the most popular workloads that we see our customers putting on Spot. And that's why this webinar is going to address all kinds of containers. It could be your self-managed Kubernetes. It could be Amazon managed services like EKS and ECS. We will discuss how to use or launch Spot when you're using those services. The week after, we have another webinar, which will do a deeper dive on taking advantage of Spot for AI/ML and big data workloads. The time, just for convenience, we have kept the time the same. So it's going to be the 10 a.m. PDT, US Western time. So historically, we have found that these are the reason we are focusing on these 3 workloads is because we find that they are the most popular ones. But then if you want to learn about a different workload, like we have shared that Spot can work with CI/CD, stateless web services, HPC. So if you want to learn about a different workload, like do a deep dive webinar, let us know in the chat window.